Alright, what's going on, guys? So here we have part 5 of chain rule. This one might be the last one for the chain rule, and then we move on to implicit differentiation. Okay, so here we have a problem. It is y is equal to e sine 2x plus sine e to x, or e, the first term should be e to the power of sine 2x, but you guys know what I mean. All right, so we're going to take the derivative of each of these two terms. The first one, we will need to use the chain rule again. It's just chain rule after chain rule after chain rule, as you guys know. So let's go ahead and write that down separately for each of these. And then we're just going to ask ourselves again, as we do with every single problem, what is the inner function, what is the outer function? The inner function here, okay, will be sine 2x, okay? It is sine 2x, okay? When we are dealing with the function e, the inner function will be the exponent here. And the outer function, of course, is e. And we do know, as the rule, when we take the derivative of e, the first thing we do is just take or rewrite the e to the power of whatever the function is. And then all we need to do is multiply by the derivative of whatever the exponent is, whatever the function is as the exponent. So let's do just that. So all we have to do for the first term is rewrite e sine 2x and then take the derivative again of that inner function, or the exponent here in this case, which is sine 2x. Okay, we're dealing with the first term right now. We'll do the second term in a different color, but right now we're just working with the first term. Okay, so we rewrite this. So e sine 2x, or e to the power of sine 2x, multiplied by the derivative. Again, this is chain rule again. Okay, this is going to be the derivative of sine, which is cosine, and we rewrite sine 2x, or 2x, I should say, and then take the derivative of the inner function, as you can see here, which is just 2x. So then we are left with just 2 cosine and then 2x, and that's it. So we're going to rewrite that. We'll put the 2 on the outside here, erase these two dots here, and then we just write cosine parentheses 2x, and we're done with the first term. So I'm going to give you guys time to write this down real quick, so pause it because I will be erasing this. Alright, so let me go ahead and erase that. And now we're going to be working with the second term of this problem. As promised, I'll do this in a different color so it doesn't look all confusing. We'll do it in blue. Alright, so now let's do this. Again, it is what is the inner function, what is the outer function. The first one we'll work with is the outer function. Again, this rule is just, we'll rewrite this as cosine and then whatever the function was on the inside, in the inner parentheses there, which is just going to be e to x. And then we just take the derivative of what was inside the parentheses, or in other words, the inner function, which is here e to x. And again, this is basically what we did with the first term. This part here is basically what we did with the first term. So we're going to rewrite cosine e to x. Sorry, that doesn't look really much like an e. Let me rewrite this. E and then 2x. And so, again, the rule was to just rewrite that function, e to x, and then take the derivative of the inner function, or the exponent for this e function here, which is 2x. And the derivative of that, we'll rewrite this again, e to x times e to x. And the derivative of 2x is simply just 2. So we're going to go ahead and write plus. Do not forget the plus. And we'll write the 2 first, and then the exponential function here, e to x, and then cosine e to the power of 2x here. And that is your final answer for this problem, this part right over here. All right, so here is our second problem. I know it looks confusing here, but it's tan parentheses secant parentheses cosine t and then the two closed parentheses. So as with any other problem or with any problem, it's always going to be what is my inner function, what is my outer function. And the outer function is the one that we work with first. The outer function here is tan. And then the inner function is the one that comes after the first parentheses. So the inner function, we're going to go ahead and change this to blue. The inner function will be what's inside after the first parentheses. All right. And then the closed parentheses obviously closes that. So the inner function is 10. So the first thing, or the outer function is 10. So that's the first one we work with. We take the derivative of 10, which is going to be secant squared, and then whatever the function is. So if you want to write that down, that rule, you can. It is just the derivative of 10. We'll just say f of x is equal to secant squared, and then f of x, and then you take the derivative of f of x. So that's really the rule. A lot of books will have it just tan x. The derivative of tan x is equal to secant squared x. But thing is, you don't see anything else because the derivative of x, which is technically the inner function, is 1. But anyways, we'll rewrite this here as secant squared. So we just took the derivative of tan, and then we rewrite the inner function, secant cosine t, and then the two closed parentheses. And now we take the derivative of what was the inner function for this problem, which is the derivative of secant cosine t. And as you can see, we are going to have to use the chain rule again. So we're going to rewrite this left side here, what's in white, a little later. We'll just work with what's on the right in blue first. Okay, so the outer function, again, always ask yourself, okay, outer function, all right, what is it? All right, well, it's the one outside of the first parentheses here, which is secant. So the derivative of secant is going to be secant function tan function. And then you take the derivative of that function. So again, what that looks like is secant, and the inner function here was cosine t, and then multiplied by tan, and what was the inner function again. And then take the derivative of, well, we shouldn't be writing x, it should be t, dt. So did I write x anywhere else? Yes, I did. dt, there we go. And then cosine t. Yep, something's wrong with my handwriting now. There you go. And we just finished by taking the derivative of cosine t, which is going to be negative sine t. So we'll put the negative on the outside here. So we'll put negative, and I guess we could put the we'll put the multiplication afterwards. So secant cosine t times tan cosine. Well, I'm thinking the parentheses is the c here, and then sine t. And then we can rewrite the whole thing as, let's write this in white. The whole thing would be, of course, we're multiplying by negative, so we could just put the negative on the outside. Secant squared, secant cosine t, and then the two closed parentheses for that one. And then we just rewrite this part here and the rest. So secant cosine t, a lot of parentheses here. Tan cosine t, and then sine t. And this is the final answer. All right, so here we have a fairly easy one. I wanted to bring this back because now we have technically an exponent of 3. As you can see, right after the sign, you see an index there, an exponent, which is cubed, or 3. As with any function that looks like this, what I like to do is always just take that exponent and just add parentheses and then add that exponent back outside of those parentheses. So what do I mean by that? So we're just going to rewrite this. We're going to take out the exponent and just rewrite everything as written here. Cosine x squared, and then the two close parentheses. And we're going to add parentheses, so that means we're adding on the outside, and then adding back that exponent, cube. So that's really what's going on here. That's why you see a cube over here, because the whole function is being cubed. Okay, now we can use the power rule. So the outer function here is just using the power rule, and that will be 3 parentheses sine cosine x squared, and then squared. That's power rule there. And then all we need to do is take the derivative of the inner function. It looks a little confusing. I feel like we're missing a parentheses here. I think we are. Yep, we are missing a parentheses. Multiplied by the inner function, which was the cosine, or everything here, I should say. See, I'm almost getting confused because there are a lot of parentheses. The inner function is everything that was inside the first. Remember, I always forget here, too. Not the only one, I hope so. The inner function is always the one after the first parentheses. So, of course, the first parentheses is right here. So the inner function is sine cosine x squared. So we'll take the derivative of sine and then cosine. Whoops. I always think the first parentheses is the c. And I'm not the only one to do that mistake, I think. But cosine x squared, and there are just, yep. And that's it. No exponent here. Again, chain rule. So we'll rewrite this first part with the 3 a little later on. So we'll work with the derivative first. So we're being multiplied by that derivative sine cosine x squared. So the outer function, again, we're using chain rule. The outer function here is sine. So the derivative of that is cosine. And then we rewrite what was inside of that parentheses. And then take the derivative of cosine x squared. Okay, and again, chain rule. Again, a lot of chain rule in this one. We'll rewrite this cosine, and then cosine again, x squared, close parentheses. The outer function here is cosine, so the derivative is negative. So we'll just put the negative on the outside here. The derivative of cosine is negative sine. We rewrite the inner function, and we have to take the derivative of the inner function, which is x squared, and that's just going to be 2x. So we're going to rewrite this whole thing now. Well, let's rewrite the right side. And it's going to be negative 2x. So again, we took the derivative of x squared, and I'm just moving it to the left side so I could write all the trigonometric functions over on the right. And then cosine again, parentheses x squared, parentheses, times sine, parentheses x squared. We already did this. I already put that on the left. And then, of course, you can't forget. Actually, let's move this negative since we're rewriting it. Let's move it on the outside here. Negative 3 sine, cosine x squared, and the one final parentheses there, squared. And that, ladies and gentlemen, is your final answer.